Assuming no air resistance or forces other than the Earth's gravity, the height above the ground at time t in seconds of a falling object is given by this equation. Now, this is something that you will likely see again in physics and in calculus. This is the equation that governs the motion of something that's acting under Earth's gravity that's near the surface of the Earth. And the first term, so S of t is its height, and the first term, negative 4.9 t squared, is the term that is due to gravity. So it's negative because gravity is pulling down on it. And the next term, the plus that's read v naught t, which means the velocity at the start. And so that'll depend on if you give something a velocity either upward or downward as you start, or if you just drop something. The next term, the S naught, is the height at the beginning. So that will be 0 if you're on the ground. If you're up on a cliff or on a mountain and you're throwing something that'll go off the mountain or off the cliff or whatnot, then this S naught would be how high you started. You can see that with this motion that it is a quadratic. It's a t squared and it has a negative coefficient. So basically it's an upside down parabola, or parabola that opens down. Okay, part A said, what does v naught greater than 0 mean? And v naught was the initial velocity. So this is initial velocity. So this could be if you threw it, or you shot an arrow, or you launched a rocket, or whatever. Initial velocity greater than 0. Now, greater than 0 is positive, so looking at this equation, if the v naught was positive, it would be adding another term on, so it would be adding to the height. If the velocity is positive, it means it's adding it in the upward direction. Okay, what is the applied domain? And so now on this applied domain, they are giving me numbers for the v naught and the s naught. So the velocity at the beginning and the height at the beginning. And it wants to know the applied domain. So when you think about this parabola, if you didn't have an application to it, the domain would be all real numbers. But that's not going to make sense in a case like ours, because let's draw a picture. This plus 35 means we started up 35. So let's have this be the ground, and you're up on some cliff up here, and that was 35 feet high. So it's going to start there. And this is plotting over time what its height is going to do, and it's a positive velocity. It's going up, so it's going to go up and gravity's going to pull on it, then it start to come down, but then it's going to keep coming down until it hits the ground here. And so the domain is not going to be all real numbers, because if you trace this parabola out, it would keep going back this way and it would keep going this way, but those do not have an application to our problem, so we need to restrict it from here to here. And so that's what is called the applied domain. So we know the left-hand side of that will be we're starting when time equals 0, and if we put 0 in this function for t, we'll be at 35, and that'll give us this starting point right here, because that is the point 0, 35. So that's where our model starts, but then it's going to stop at the point when this object is on the ground. So we've got to find that point. And how do I find that point? Well, I would need to find the 0. There's 2 zeros. There'll be one over here that's not going to be in the domain, and then there will be one over here. So we need to take this and put it in the quadratic formula to find out what this last number that we could use is, so the end of the applied domain. So we're going to have negative b, that's negative 24.9, plus or minus the square root of b, which was 24.9 squared, minus 4 times a, which is negative 4.9, times c, which is 35, and then that's all over 2a, which is negative 4.9. Okay, so you're going to put that in a calculator and get a couple approximations. And so I worked at once with the plus and I got negative 1.15, and then I worked it with the minus and I got 6.23. I believe this usually asks you to one decimal place. We're going to answer this to one decimal place. So our upper limit on the domain is going to be 6.2. And it can equal things between 0 and 6.2, and you can see by my picture why that's the case, and anything outside of there doesn't apply because it will keep trying, the function itself will keep tracing this parabola, but the object is just sitting on the ground not doing anything, so we have to stop it at 6.2. Okay, let's look at part C. Suppose the object is propelled upward from the ground with an initial velocity of v0 equal 40 meters per second. What is the object's maximum height above the ground? Okay, so we're starting upwards from the ground, so let's write our equation. This one would be the equation that fits part C, and it's going to be negative 4.9 t squared. That's the gravity pulling down term, and then the next term is for our initial velocity, and it said that was 40, so we need to put that in for v0, so plus 40t. And then it said it started on the ground, so S0 is the starting height, and I don't need to put that term in because it's just plus 0. So our first question, number 1, what is the object's maximum height above ground? So we're going to be after the vertex again, and we can do negative b over 2a to find the time that it's at its maximum height, and then we can plug that time in our function and find out what the maximum height is. So we're going to find the t value of the vertex. It's going to be negative b, which is negative 40, over 2a, and a was negative 4.9. So that's going to be approximately I'm going to carry it out 4 places so I don't have a rounding error. So when I put that in the calculator to 4 decimal places, there it is, and I'm going to put that in the function so I can find out what the maximum height is. So we just have that, and I just leave it in my calculator and use the answer button to plug it in there where I need it. So we're going to put it in there and then punch buttons and find out what that value is. And when I put that in there, and I'm going to round the final answer to 1 decimal place, that's going to be 81.6 meters. Okay, so that's number 1. And number 2 says, when does the object hit the ground? So we're going to take this function, and to figure out when it hits the ground, that's when its height is 0. So we're going to take the negative 4.9 t squared plus 40t and put it equal to 0. I'm going to factor out a negative t. That will leave me 4.9t minus 40 equals 0. So t equals 0, it was on the ground. Obviously that's when it started, so if we set this equal to 0 and solve it, we get t equals, I'm going to go to 1 decimal place, 8.6, and let's put in our units, which are seconds. So that's when it will hit the ground. Now I still need to answer part D, and I need some room to do that, so I'm going to erase this other part so that I've got room to work that out. I'll put it right here at the end. Okay, so looking at part D, suppose the object is propelled upward from S0 equal 35 meters above the ground with an initial velocity of 40 meters. Okay, so let's write down that equation for part D, and that's going to be S of t equal negative 4.9 t squared, and then I need to put in v0 t. I'm just using this equation above, and so that'll be plus 40t and then plus S0, so plus 35. So this is my equation for part D. And the question was, when does it hit the ground? So we need to figure out when this equals 0. And it's going to be another quadratic formula. So we'll find the time when it equals 0, which is essentially when it hits the ground. So we're going to have negative b, which is negative 40, plus or minus the square root of b, which was 40 squared, minus 4 times a, which was minus 4.9, times c, which is 35. This was 4.9, all over 2 times negative 4.9. And again, because this was up 35, if I compute the positive one, put that in the calculator, I get t is approximately negative 0.1, and we don't count that one because that was, again, finding this place, if I'm showing you back up here in the parabola where but that's not part of ours because we started up 35. So I need to compute the other one that uses the negative sign here, and I get t is approximately, I get 8.96, so that'll round to 9 seconds. So it's going to hit the ground in 9 seconds.